In this experiment, we are going to perform permanganometry. Redox titration. Chemical reactions which involve oxidation and reduction are called redox reactions. In titrimetric analysis, oxidants are titrated against reductants. Such titrations are called redox titration. Permanganometry. Redox titrations which involve titration of potassium permanganate as the oxidant against reductants are collectively called permanganometry. Potassium permanganate is a powerful oxidizing agent in acid medium and it gets easily reduced to colorless manganese ions in redox reactions in accordance with the equation. MnO4 minus plus 8H plus 5E minus gives Mn2 plus 4H2O. 5. The oxidation number of Mn decreases by 5 from plus 7 to plus 2. The equivalent mass of KMnO4 is equal to formula mass divided by 5, which is equal to 158 divided by 5 equal to 31.6. In the titration of a definite volume of a colorless or slightly colored solution of a reducing agent against permanganate, the use of an indicator is unnecessary since as little as 0.01 milli of 0.02 milli KMnO4 imparts a pale pink color to 100 milli of water. So, the appearance of a permanent pale pink color immediately after the equivalence point marks the end point of titration. Potassium permanganate thus functions as a self-indicating reagent. Potassium permanganate is not a primary standard as it is always contaminated with traces of manganese dioxide. So, it is standardized using a standard solution of a primary standard like crystalline Morse salt. Let's perform the standardization part. Place the weighing paper on the electronic balance and tire the balance. Take some more salt crystal and transfer them to the weighing paper and weigh 3.920 gram to make up 0.1 normal solution of more salt. Transfer the weighed quantity of more salt into standard flask using funnel and glass rod. At the same time, wash the weighing paper, glass rod and funnel to avoid the wastage of a minute crystal of more salt. Add distilled water slowly to the standard flask and make up to 100 ml till it reach the lower meniscus and shake it well. Take a clean burette, rinse it with distilled water and drain the water. Repeat this process 2 or 3 times to drain out the impurities from the burette. Then pour a small volume of potassium permanganate solution into the burette. Rinse the burette and drain out the solution. Repeat this process 2 or 3 times to remove any moisture inside the burette. The next step is to fill the burette with potassium permanganate solution till the upper meniscus reach 0. Upper meniscus is considered for colored solutions. Remove the air bubbles, if any, from the nozzle of the burette by releasing some solution through it. Now pipette out a small volume of Morsol solution to rinse the pipette. Repeat this step 2 or 3 times and pipette out the Morsol solution from the standard flask till the lower meniscus is on the calibration mark. And now the volume of the solution is 20 ml. Transfer the 20 ml Morsol solution into clean conical flask. Now add 20 ml of dilute sulfuric acid to the more salt solution in the conical flask. Then place the conical flask on the white surface of the stand under the burette to correctly view the color change. Run potassium permanganate solution dropwise to the conical flask with constant shaking of the solution in the conical flask. Continue this addition of potassium permanganate from the burette to the conical flask till the solution in the conical flask changes from colorless to light pink color on addition of the last single drop of potassium permanganate. This is called the end point. Note down the final burette reading and repeat the same procedure until concordant values are obtained. Next, let's do the estimation part. Estimation of oxalic acid using potassium permanganate. We are provided with oxalic acid in a reagent bottle. Transfer this oxalic acid into a standard flask using funnel and add distilled water slowly into it. Then make up it to 100 ml. Close the standard flask and shake it very well. In pipetting, repeat the same steps as we have done in the standardization part and transfer the 20 ml pipetted solution into the conical flask. Add 20 ml of dilute sulfuric acid to the 20 ml of oxalic acid solution. Then heat it to 70 degrees Celsius. Fill the burette with potassium permanganate solution till it reaches the value 0. Then place the conical flask on the white surface of the stand under the burette to correctly view the color change. Run potassium permanganate solution dropwise to the conical flask with constant shaking of solution in the conical flask. Continue till color of the solution changes from colorless to light pink. Note down the final burette reading and repeat the same procedure until concordant values are obtained. Now let's do the calculations. Volume of potassium permanganate used in standardization part is equal to 18 ml. Volume of potassium permanganate used in estimation part is equal to 16.4 ml. Calculation for standardization. Mass of more salt in 100 ml solution is equal to 3.920 gram. Therefore, normality of more salt solution is equal to mass per liter divided by equivalent mass, which is equal to 3.920 into 10 divided by 392 equal to 0.1 normal. Standardization. Volume of more salt pipetted is equal to 20 ml. Volume of potassium permanganate used is equal to 18 ml. Volume of more salt into normality of more salt is equal to volume of potassium permanganate into normality of potassium permanganate. From this equation, we get the normality of potassium permanganate, which is equal to volume of more salt into normality of more salt divided by volume of potassium permanganate. That is equal to 20 into 0.1 divided by 18 equal to 0.111 normal. So here we get the normality of potassium permanganate as 0.111 normal. Calculation for estimation. Volume of oxalic acid pipetted is equal to 20 ml. Volume of potassium permanganate used is equal to 16.4 ml. Therefore, volume of oxalic acid into normality of oxalic acid is equal to volume of potassium permanganate into normality of potassium permanganate. From this equation, we get normality of oxalic acid as volume of potassium permanganate into normality of potassium permanganate divided by volume of oxalic acid, which is equal to 16.4 into 0.111 divided by 20 equal to 0.091 normal. Therefore, mass of crystalline oxalic acid per liter is equal to normality into equivalent mass. which is equal to 0.091 into 63 equal to 5.733 gram. At last we get mass of crystalline oxalic acid involved of the given solution as 5.733 divided by 10, which is equal to 0.573 gram. And that's all about permanganometry. Thank you.